Do you run distributed workloads on Kubernetes or GKE? If so, you are probably having to manage more and more services. And it's getting harder and harder to understand what's going on if there are any issues. This is where a service mesh can help. A service mesh is a dedicated infrastructure layer that you can add to your clusters. It gives you capabilities like observability, traffic management, and security without having to modify application code. My name is Yuri. I'm an SRE at Google Cloud. And today I'm going to show you how to use both the open source version of the Istio Service Mesh and Google's managed Anthos Service Mesh to get better observability for your services running in GKE. This is engineering for reliability. The Istio Service Mesh works by adding Envoy proxy sidecars to your services running on GKE. These proxies intercept all service-to-service traffic in the mesh and enable the application-aware features like security, traffic management and routing, and observability. This is the data plane. The control plane dynamically programs the proxy sidecars, updating them as the rules or the environment change. Your first option for using Istio on GKE is to simply install the open source distribution in your cluster. This is the way to go if you prefer to have the most control over your deployment, or if you have existing dependencies on features that may not yet be available in Google's managed offering. Istio includes an open source observability toolkit. You can use Prometheus for metrics and Zipkin or Jaeger for analyzing tracing. You can also enable proxy access logs and have the proxy sidecars write out logs for every request in the mesh. Let's have a look at how you can use this toolkit and centralize all that telemetry to cloud operations. In our example, we have an application running in the Istio demo namespace. We have the Istio control plane and observability components running in the Istio system namespace. This includes Prometheus for metrics and Kiali for observing traffic in the mesh. If, for example, we want to look at the request rate for our services in the mesh, we can use the istioctl dashboard Prometheus command. And run a query like this. If we want to visualize how traffic flows between the different services in the mesh, we can use Kiali. At each node, we can see how much traffic the service is seeing and what the response time looks like. Finally, we can enable request logging for the Envoy sidecar proxies by using the telemetry API. We can then view those logs in the terminal. Now, let's have a look at how we can get this telemetry into cloud operations. To adjust the Prometheus metrics, we can actually use Google's managed Prometheus binary. Just by replacing this image tag. This allows us to query Prometheus metrics in Metrics Explorer. Here's that same request rate query. The proxy sidecar request logs are automatically ingested into cloud logging. And we can query those too. So, through the combination of Google's managed service for Prometheus and cloud logging, we can get metric and log telemetry generated by Istio ingested into cloud operations and use it just like other telemetry from your infrastructure and services. If you want to maximize control over your Istio deployment, and possibly have experience with Istio already, using the open source distribution is the right way to go. However, if you're new to using a service mesh, or would simply like a more managed experience, there's the Anthos Service Mesh, or ASM. It's a tested and supported distribution of Istio, giving you all the benefits of a service mesh with full Google support. If you'd like to control version upgrades yourself or have existing integrations you depend on, you can deploy ASM with an in-cluster control plane. Let's have a look at such a deployment and how it automatically sends telemetry to cloud operations. Let's first have a look at our cluster. The control plane pods are running in the Istio system namespace, just like what we had when we installed open source Istio. Our application pods are also instrumented with the Istio proxy containers. Now let's have a look at the telemetry that the Anthos Service Mesh collects. The Anthos Service Mesh homepage in the Cloud Console has a list of the services that are running in the mesh in our cluster. We can select a service and get some basic information about it, like request rates, error rate, and average latency. The topology view here shows us how the service sends and receives traffic. The metrics screen allows us to see these metrics over time, broken down by various dimensions. Finally, we can get error logs for our service by going to the diagnostics screen. We can click out to the Logs Explorer to get more details about these error logs. This is also where we can view the access logs for our services. We can get more metric telemetry in Cloud Monitor. For example, we can run a query like this to get a breakdown of request rates by service. So this is how you can use telemetry automatically ingested from the in-cluster ASM control plane to understand the behavior and health of your services. If you're just starting out with Istio or would like to use a fully managed service, you can use Managed ASM. In this deployment model, the control plane is fully managed by Google and does not run in your cluster. It does mean that some features like custom metric adapters won't work. If you need advanced features like these, the open source distribution may be the way to go for you. If not, let's have a look at a managed ASM deployment and how its telemetry is automatically ingested into cloud operations. Let's again start by looking at our cluster. In this case, we don't actually have any Istio control plane pods running in the Istio system namespace. The control plane is entirely managed by Google, and there are no control plane components running in the cluster itself. Our application pods, however, are still instrumented with the Istio proxy sidecar container. Now let's have a look at the collected telemetry. Just like before, we can look at the services running in our cluster. For all of them, we can get the same basic telemetry, including the topology view, we can get the same metric telemetry, and we can get the same access logs. All of this is made available via the managed control plane, without the need to have anything running in the cluster itself. Thanks so much for watching today. We learned how a service mesh improves observability for distributed workloads run GKE, and how you can use cloud operations to get telemetry from both open source Istio and the Anthos Service Mesh to observe your own services. I hope this helps you to keep your applications reliable and your users happy. Don't forget to like and subscribe to never miss out on more engineering for reliability with Google Cloud. See you soon.